Alrighty. So, got some trapping rainwater hard. Previously have solved this for some reason. So I kind of remember this one in the sense that I definitely remember this diagram, and I remember the extremely hard difficulty this problem was, and getting stumped by it. But I guess I solved it, and let's see if I can try to recreate or if I can um, find whatever I found last time. Given an n by n matrix of height maps representing the height of each unit cell in a 2D elevation map, return the volume water can trap after raining. So there you have a 2D array. The heights of the thing here are for the slices of heights for each kind of 2D slice of this thing. So this is actually, I think the 0, 0 is on the side. So like this is 0, or height here, back here is 1, then 4, then 3, then 1, then 3, then 2. The 1 and the 3 is kind of hidden. And the second slice is 3, 2, 1, 3, 2, 4, and then the frontmost slice is 2, 3, 3, 2, 3, 1. And there's a pool here that's like, I guess, 2 deep. 3, 2. No, so it's 1 deep here, 2 deep here. I think it might be 3 deep here. No. 1, 2, is 1 deep here. So that's a total of 4. This second one is kind of a perimeter that is all 3s. 3 in the front, 3 in the back, 3 on the sides. And then the inside of the thing is 2, 2, 2, 2, 1, 2, 2, 2, 2. So it should have 9 and then like a 1 in the center. That makes 10. Alright, so I don't remember how I solved this. This feels like it was part of maybe monotonic arrays, maybe? Monotonic stacks. But if this was a one-dimensional thing, or a two-dimensional thing rather than three-dimensional thing, where you're given heights of a single kind of slice, and then have to calculate the water filled in that, I think that's a lot easier. But this is, yeah, I don't know. So what comes to mind is for each spot, if I can determine how high the water should rise to that spot. How high the water should rise to that spot. Then I can determine how high the water should rise to that spot. And maybe I can find it. I wonder. Can I think of it in terms of... So one thing is that the water will always leak out if it's a lower to a higher at the very edge. So if it goes from 2 to 3 here, the water will seep out this way and there's no actual... It's not like there's an infinitely high kind of boundary to the shape. So water doesn't seep here, it has to be contained by higher cells. So if I did it in terms of two calculations where I calculate based on slices that are slices based on one facing, so like based on the length, and then slices based on the width, and consider how high the water would go for each slice, and then consider the height of the water to be the maximum height from either directions of slicing, then maybe that might work. So like a simple exercise would be if it was something like want it to be what's an example I'm thinking of? Let's say it's like 3 by 3 in terms of the base, so maybe like 5, 5, 5 on one side, and maybe 5, 5, 5 on the other side. And if this was something like 6, 4, 6, so this is one orientation of it. Like the other orientation of it would be like something like 5, 6, 5, 5, 4, 5, and 5, 6, 5. Right? So if I consider water, for this slice, water just wouldn't pool. For this slice, water would pool in the second, in the middle, at 2 deep. And then for this slice, water wouldn't pool. So, or maybe the height of the water here would just be like flat. The water would go up to 5 here, the water would go up to 6 here, and the water would go up to 5 here. And then I would look at it from that section, and then look at it from the other cross section. The water would go 5, 6, 5 here, because it wouldn't pool. It wouldn't pool at all here. 5, 5, 5 here, and 5, 6, 5 here. And if I take the minimum of how high the water pools, slicing it in this way versus slicing it this way, minimum of each cell, then it would eventually get to 5, 5, 5, 5, 5, 5, 5, 5, 5, and then I take the difference between those values. Yeah, take the minimum, take the difference between those values, and what I have here or here, and if it's positive, then there's pooling, and if it's negative, then there's no pooling at all. Or if it's zero, then there's no pooling. Maybe that works. So this thing should have heights of okay, so 1, 4. So if I think about 1, 4, 3, 1, 3, 2. The water would go up to a height of 1, 4, 3, 3, 3, 2. The water would pool right here. It would drain out here. It would drain out on the other side here. And then the middle thing would be 3, 2, 1, 3, 2, 4. Higher the water would be, it would pull up to the 3 here. So 3, 3, 3, and then 3, 4. It wouldn't go higher than, yeah, it wouldn't go higher than this 3. And then last slice is 2, 3, 3, 2, 3, 1. So the water drains from the side, 3, 3, pulls up to 3. This would be 2, 3, 3, 3, 3, 1. And then looking at the cross section the other way, it's like 1, 3, 2, 4, 2, 3, 3, 1, 3, 1, 3, 2, 3, 2, 3, 2, 4, 1. So this thing doesn't pool at all. The height of the water would just be 1, 3, 2. 4, 2, 3, that pools and becomes 4, 3. That's 3, 3, 3. That's 1, 3, 2, 3, 3, 3. It doesn't pull at all. 2, 4, 1. I guess I need to transpose this in order to actually compare it to this. So if I transpose it, making sure I get this orientation right. This 1 maps this 1, so this 1 maps that 1. So this first column is the row. So transpose. It's 1, 4, 3, 1, 3, 2. 3 is a 4. 2, 3, 3, 2, 3, 1. Okay, so this is the original. Or this is the height of the water is based on the basing that they're giving you. So the water pools horizontally up to these heights and pools kind of vertically, and pools lengthwise up to these heights and widthwise up to these heights. And then the minimum of those is what I'm looking at, I guess. So the minimum of these two arrays is 1, 4, 3, 1, 3, 2. All threes 4, 2, 3, 3, 2, 3, 1. And then if this is higher than the original, then that means there's some water cooling. So 1, 1, 4, 3, 1, 3, 2 is the same in the first row, on the first slice. And then 3, 3, 3, 4, it's bigger than this by 1, this by 2, this by 1, so that's 4. And then 2, 3, 3, 2, 3, 1 is the same as the last slice. So there's no water cooling there. Okay, I think maybe that might work. So then if I think about each kind of slice, how to determine the correct translation between that slice and how the water would cool. 1, 4, 3, 1, 3. 1, 4, 3, 1, 3, 2 needs to somehow become 1, 4, 3, 3, 3, 2. So if it starts low and increases, then there can't be any cooling. So I think I do a monotonic decreasing. 1, 4, 3, 1, 3. Okay. So just one-dimensional cooling, or two-dimensional rather than three-dimensional water cooling. Goes down. I think I want to go monotonic decreasing stuff. Goes up. Goes up, then if it goes up, then it should indicate some pooling. So 1 to 3, if this was a 2, 1 to 3, then it should pop this 1, 1, 4, 3, 3, 2. One for those monotonic decreasing. Monotonic decreasing. Maybe. Maybe I do monotonic decreasing. So the stack goes 1, and then if it increases from there, then there just can't be any pooling. So then it just becomes 4. And then stack has 3 because that doesn't really cool. And the stack has 1, that doesn't cool. And the stack has 3. 3 has to cause a pooling here. Maybe I need to do like 4, 1, or how long it's for. 4, 3, 1. And then it gets popped. 3 doesn't get popped. So let's come 4, 3, 3, 2 to recognize that there's like 2 3s there. And then a 2. So that's the height, 4, 3, 3, 3, 2. What if it was something like, what if my thing was 1, 4, 3, 1, 4, 2? Then it comes 1, pops for 4, 3, 1. This 4 pops these. So it's like a 4, 3. Then a 2. So it's like 4, 4, 4, 4, 2. But what if it was something like a 5? What if it was 1, 1, 4, 3, 1, 5, 2? There's 1, 4, 4 pops to 1, 3, 1, 5, 5 pops. 5 needs to make this 4 become like a 4, 3, where it's like 3 4s in a row, and then 5, 2. Interesting. So if it's a bigger number, then the smaller number needs to be repeated. Oh, okay. So if it's a 1, then a 4, then I know that 1 is in the final result. So when it pops to 1, I know for sure that 1 goes into the final height, because there's no way it ever gets higher than 1. So the 4, 3, 1, and then there's 5 here. Hmm. 5 should pop 1, 3, and the 4. When it pops it, it needs to actually, when it pops it, is it guaranteed to know the height of the water? 4, 3, 1, 5. Yeah, I think so, maybe. Well, what if it was like 20 here? 1 gets popped, 3 gets popped, 4 gets popped, and this 5 becomes 5, 4. Yeah, I think. Let's go matrix 1. Let's say length heights. It's going to be a 2D array. Based on the elevation map of the lengths. So for every slice, for every length slice in the height map, and you have like a mono array. And the mono array should start with the first value in the slice. And then go through the indices. Let's say the length, let's say x is just the length of length slices. Should be height maps of 0. So it's basically the width. So if this is the length slice, then for every index in range 1 to x. I feel like I'm doing this really wrong. It's not how you do monotonic stacks. Whatever, okay. The height is going to be the length slice at this index. And if the height is bigger than the top of the stack, or if the height is smaller than the top of the stack, that's good. So but if it's not, then it needs to pop top of the stack. So while the height is bigger than the top of the stack, maybe it's also bigger than or equal to. And maybe the top of the stack needs to have a tuple of the height and the length of things. So maybe this should be slice length is going to be a default to 1. So while height is greater than mono, it should pop it. And it should keep track of how much the length of the things it pops. So pop length plus equals mono should be, since it's a tuple, the height is the first element. Mono dot pop, and then the second element of that tuple. So if it goes 4, 3, 1, so 4, 3, 1, 5, 2, it goes 1, 1 is the top of the stack. It pops it. Then it has the 4 because 4 is bigger than 1. And when it pops it, it recognizes the height. It recognizes the amount of height that is popped as 1. And then what? So it pops it and becomes an empty stack. If the stack is empty after that, then it should probably put that onto the final array. If not, mono stack at that point. If stack empties, put popped onto final heights. Kind of need to know what the height of the last thing that was popped. 4, 1, 4. So increments by the length there, and then the last height is mono.popped 0. Stack empties, put popped on onto the final height. So I think this should be height equals length slice index. I guess I need another array here. I think I need another array. With popped back empties, put popped onto final heights. So I think this final plus equals bracket. I think maybe final dot extend by the array that is the last height times the popped length. So it goes 1. First thing is 1, puts a tuple 1, 1. Then the 4 pops the 1, 1. That causes the final height to be a 1. Exactly 1, 1. Okay. Else, if there is something left on the mono stack, like say there's a 4, 3, 1, and then another 1. I want to consolidate the ones. So if else no, I'm missing a step here. If I pop it, okay, I think I need to make sure if popped length is greater than 0. Okay. So if there was some stuff that was popped, so for instance, there was a 5, so the small stack is 1, 4, 3, 1, 5. So pop the 1, pop the 3, pop the 4. Okay, that's more than one step. So it's 4, 3, 1, 5, 2. 4 is on the stack, 3 is on the stack, 1 is on the stack. 5 pops the 1, pops the 3, pops the 4. And now there's nothing left. So it'll do 4 times 3 as the height. But if there was something left, right, if this was like a 20, 4, 3, 1, 5, it'll pop the 1, pop the 3, pop the 4, but it'll keep the 5. In which case, it should put onto the stack 5 in pop length plus 1. Becomes 5. I guess there's no else then. Pop length is greater than 0. I think this means that pop length should be set to 0 here. And then you automatically put into the stack mono append current height, which is height, and whatever the pop length was, plus 1. So the stack is 20, 1, then 4, 1, 3, 1, 1, 1. 5 pops to 1, 3, 4. Makes the length of 4, or makes that pop like 3. With additional 5 is going to be 4, so it'd be 21, 5, 4. 20, 1, 5, 4. And then 2 goes in the stack, which is 2, 1. I guess. That really work? So what if it was something like this? 5, 4, 3, 1, 2, 5, 2. So 2 pops to 1, 1. And then it stops once you hit 3. Then it makes this a 2, 2 in the stack. And the 5 pops to 2, 2, 3, 1, 4, 1. It's a 5. 2, 1, 1, 1, 5, 5 onto the stack. 2 puts onto the stack. Okay, what if it's like a 50 here? 2 pops to 1. 50 pops to 2, 3, 4, 20. Since there's nothing left after pops to 20, then adds onto final whatever that thing was times the popped length. Okay. And then I think I need to do something like, after this is done, after that's all done, then I need to modify the final by whatever remains in the mono stack. So for index and range of length of the mono stack, height and length is equal to mono index final dot extend by whatever that height is times whatever that length is. Alright. I'm going to go ahead and print out the final that I get. Out of range. This mono could be empty at this point. Mm, 143332. Okay, I did it for the first slice. I'm not sure why I didn't do it for the other slices. Length slices, height map, mono, length slice at 0, 1. Oh, I'm returning it. Then this thing is not. I want to just I want to print out the final. Okay, so 143332. All threes and 4, 2, 3, 3, 3, 1. Wow, that actually worked. That's correct, is what I expected. Okay, I need to do some more test cases. Let's do 5 values. Say 1, 1, 3, 5, 10, 1. 25, 5, 1, 2, 7, and say 10, 1, 4, 1, 2. So what I expect here would be 1, 3, 5, 10, 1. There's no pooling. This thing should pool and get 25, 7, 7, 7, 7. This thing should pool and get 10, 4, 4, 2, 2. See if it gets anywhere near that. Okay. I promise. Three, 5, 10, 1. Great. 25 all 7s. Great. 10, 4, 4, 2, 2. That's fucking amazing. That's actually what I wanted. Guess I should probably do just a few more test cases. So there's the double pool. I guess maybe if I did this to be 20, then that should be 10, 10, 10 to 10, 20. Wow, that's really surprising that it worked. Well, it worked in the sense that it did what I expected it to do, and in the sense that I know that's correct. So that's doing it for think maybe I need to make this into a function. Probably is the easiest. Yeah, make this into a function. Define get water height from some initial. How is this thing described? It's like all this cell heights, which is a list of integers, and this is going to return a list of integers. So I'll say the water height array is initially empty. No. Yeah, it's initially empty. And I'll say this is a monotonic stack that is having a tuple of the well, h is height. Tuple that is the first one. So cell h, cell height. I guess I can just call this the heights versus the water heights. I'll call this the waters. So the heights that were given, the first one is going to be 1 long. Huh. What happens if it's actually the same height? It doesn't consolidate, does it? If it's the same height, then it doesn't do the while loop. So it's just, I think it adds a bunch of ones. I guess that's fine. Okay. Do I need to actually start it with anything? Can I just start it empty? What if I try starting it empty? Or do I need to use an indexed loop rather than a for each loop? For each height in heights. Popped is going to be 0. Last height is going to be 0 as well. While there's something on the mono stack and the current height is greater than whatever is on the mono stack height, then popped increments by the length of one. And then the last is equal to mono.pop. If there was something that's popped and if the mono stop and if the mono is empty, mono stack is empty, then the final height, which is going to be called water, extend by whatever the last one that was popped times the popped total amount, and popped is now equal to 0. And then otherwise I'll do mono append current height and popped plus 1. So if it's a bunch of things that are the same, it doesn't really consolidate it. It's like 1, 1, 1, 1. I wonder if I can try to consolidate that, or if I should. If it's a bunch of things that are the same, while mono and height square then are equal to, so it's equal to, then it pops it. Pops it, immediately adds it to the thing. Yeah, it doesn't really, it doesn't know how to consolidate. Guess that's fine though. Okay. And then I need to do this final for loop for every index in the range of whatever the length of mono is after this. The height and the length is equal to mono index, and then the water height is going to be extended by the height times the length, and then return the water height. Okay. Let's see if this works. For every length slice, then I'll say array is equal to get, I think this might work. Don't know. I might need to make this more explicit. Syntax errors, height, mono.append. This should be extend. No, it should be a tuple. Okay. So it works as before, just using the helper function now. Okay, and this worked without using the index 1 to n. Using for each loop instead. Okay, so I think that's what I want. I need x here. I'll say heights. Say matrix 1 is going to be this. So matrix 1 is going to be this. So matrix 1 appends this array. And then there's going to be a matrix 2. That is the other way of slicing it. So how do I transpose the matrix? Don't want to use the like numpy transpose. I used that before and it fucked me up pretty hard. Probably because I didn't use it correctly, but so if I want to transpose like get 1, 25, 10, 3, 1, 4. I guess I should just treat this as rows and columns. Maybe I should call these rows and columns. Whatever. Rows is the length of the height map. Columns is the length of height map at 0. And so I want to make this into 1, 25, 10. So for every I can just go through every element, I guess. This matrix should be for every column C in range of calls, and then for every R in range of rows. So I'll say array is empty here. Array appends height map at row call RC. And then matrix 2.append this array. Let's double check that this is correct. This is matrix 1. 1, 25, 10, 3, 3, 5, 1, 5, 1, 4. Okay. Maybe I should just call this row slices. Yeah, row slice. Which is the default slicing. This is now column slices. Okay, so for every call slice in this, I guess this should be height map 2. Or I can call this transpose map. Transpose map. Transpose map. So for every column slice and transpose map, now is when I make my matrix 2. Array is equal to get water heights of the column slice. And the matrix 2 append this array. And I think I can probably just figure out the answer based on that by now. So answer is going to be equal to initially 0. So for every R in range rows, for C and range columns, the water height is equal to the minimum of height map at RC and transpose map at CR if this height is greater than the original height map. No, this is matrix 1, matrix 2 actually. If this height is greater than the height map at this row and column, and it's incremented by how much higher it is. Transpose map is probably misspelled. Transpose map. Ooh, kind of. Oh boy. I was hoping to just get a little lucky. Okay, let's see what's going on here. Alright, let's go and print matrix 1, matrix 2. See if there's a hole in my logic here. Okay, so 1, 3, 5, 10, 1. No water pooling. 3, 25, bunch of 7s. 10s, and then 20. Okay. Okay, 1, 25, 10. There shouldn't be any water pooling. So 3, 5, 1, no water pooling. 10, 1, 4. So it'd be 10, 4, 4. I'm sorry, 5, 1, 4. So it'd be 5, 4, 4. 10, 2, 1. So 10, 2, 1. 1, 7, 20. 1, 7, 20. Okay, so let's go ahead and so I kind of need to see this rearranged. So array is empty, query C. Let's go ahead and array append to H. And then maybe have a matrix 3. And matrix 3 appends this row. Maybe I'll just print out this row. Okay, 1, 3, 5, 10, 1, 21, 5, 4, 2, 7. And 1, 4, 1, 20. Oh gosh, I can't visualize this. 55427. Okay, let's go ahead and print it here. Print the row that I'm dealing with, the column that I'm dealing with, matrix 1 at RC, matrix 2 at CR, and how much I'm gaining here. Right, so I'm gaining 3 and exactly one spot in the whole map. Set row 1, column 2. Row 1, column 2, so it's at this location. So it's 1, so the height, I see the height of this on the column slice is 5, height of this on the row slice is height of this on the column slice is 5, height of this on the row slice is 7. So the min of that should be 5. 1, 2, 0, 1, 2. Oh, whoops, I'm looking at the wrong one. So 5, 1, 4. So on the row slice, or on the column slice, this thing goes up to 4. On the row slice, this thing goes up to 7. So is there a miscalculation? Because it's 1 is between 5 and 4. Oh, 1 is between 5 and 2 here. Fuck. Well, what does that mean actually? This 1 is between 5 and 4 one way. That's between 5 and 2 another way. The 2 leaks out. I see. 2 leaks out on this side. So it never reaches the 7. Oh my gosh. Alright. Yeah. This attempt failed. I wonder if I made the same mistake last time too. Maybe this might work. This is definitely a leaky pool, the way that I'm calculating it.